Hi guys, my name is Abdullah Shaibi, and today we're going to talk about static friction. We're going to talk the concept of static friction. So, what is static friction? As you can see here in the one of the photos I have, it says static friction is the opposing or resistance force between two solid surfaces. So let's talk about it more. So, what is static friction exactly? Static friction is a force that keeps an object at rest. uh, the way the object is not moving when you apply two forces, either pull or push, the object is not moving. If must be overcome to start moving the object, once an object is in motion, it experiences kinetic friction. So, as you can see here in this graph, I'm going to explain it more in the next slide right now. There's two kinds of forces, which is force applied to the object, which is push and pull. And we have a different kind of force, which is a static friction, which is the resistance of these two forces. So if the object is not moving, the object, then the force should be equal. If the object is moving, then it shows that the forces are not equal, and then it comes back to an equal status because it goes back to constant speed. So when they say once an object is in motion, it can experience kinetic energy. So when the object is moving, the force is higher in the static friction. So the object, the kinetic moves the object. So now we're gonna talk about how the static friction scales higher than the kinetic. So we conducted an experiment. So first of all, I just used normal surface like a table, and we used a block and a balance spring. So the balance spring measures the Newton force of my pulling force and measures the static friction of the object. So first of all, we used no scale on it, so you can't really see the end result on this. So we have to up the the weights. So we added more weights right here. So first of all, let's do the maximum weight. As you can see, let me just pause the video, increase the quality, and yeah, yep. As you can see, now if you slow the video down, you can see there's like a weird jump towards it. Let me just slow down the video out a second. Yep. Look, it reaches the maximum force weight on the object. So as it reaches maximum, it jumps back to a like constant speed. As you can see, decreases the amount of maximum speed, maximum force. So if we do half of the weight, you see there's like this tiny jump in it, and I'm gonna explain that jump. As you can see here, this is like the result that we had in the class. Um, when we added the maximum weight, the weight just rises till the maximum weight, the maximum force that's applied, then it jumps back down to a constant. When that jump happened, that means the object is moving. So as the object jumps, then comes back to a constant speed, that shows this from 2 seconds to like forever. It's kinetic speed, right? Like right here. So at the beginning, it's static friction because it's resisting, and then it jumps back down to a kinetic friction. And to conclude, um, if a small amount of force is applied to an object, the static friction has an equal magnitude in the opposite direction. If the force is increased at the same point, the value of the maximum static friction will be reached and the object would move. And this is the equation for static friction. So this is called the coefficient of static friction, and this is the normal force. So, and there's the kinetic force actually equation I forgot to add, but you remove the s and put k instead of them. So it's the coefficient of kinetic friction. And yeah, that's pretty much it.